Okay, so we are gonna start section 3.1, estimating with decimals. So it's really important to be able to estimate to know if when we start working with decimals, if our answers are kind of in the ballpark and if they're accurate. So our objective today is to be able to estimate sums, differences, products, and quotients. So the sums, just to remind you, is when we add. A difference is when you subtract. A product is when you multiply. And the quotient is when we divide. Okay? So in our first section, we are going to estimate when we add and subtract. And we are going to round to the nearest integer. This means that that is the nearest positive or negative whole number. We are going to get rid of those decimals. Okay, so like we talked about, if it is a 5 or higher, you're going to round up to the next whole number. If it's a 4 or lower, you're going to stay right at the whole number that it's at. So 86.9 is going to go up to 87. 58.4 is going to go down or stay, however you like to think about it, at 58. Okay, then we're just doing addition. That's something you guys did in like first grade, I think. And you just add 8 and 7 is 15. 8 and 1 is 9 plus 5 is 14. So our estimated answer is 145. So if we added this as decimals, we should know that our answer should be around 145. Not exact, obviously, but it should be around there. Letter B. You guys are going to take the 10.38, and that would go down to a 10. 58.54 would go up to a 59. This one we can just do in our head. 10 plus 59 would give us 69. Okay, so letter C, I give us a negative number here. So 26.3, we could round that to just a negative 26. That 3 makes it go down. 15.19 would just go to a positive 15. Now we are dealing with a negative and a positive. And when we have a negative and a positive, we actually have to subtract these two. So because there are more negatives, that one goes up on the top, and there are less positives. So I take 26 minus 15. 26, or 6 minus 5 is 1, and 2 minus 1 is 1. Now it is a negative 11, and I know this because there are more negatives. Okay, our next one. I have 28.3, which should just round down to 28. 11.7 would actually round up to 12. And then if you can't visualize it, you just have 28 minus 12. 8 minus 2 is 6. 2 minus 1 is 1. So our answer is 16. Okay. Any questions on adding or subtracting those decimals? Okay. So we're going to move on to multiplying and dividing. These are a little bit different, okay? The theory behind these, you want to make estimation easy for yourself, okay? And so when you're multiplying, sometimes rounding it to the nearest whole number is enough, and other times you're going to choose easy numbers to multiply. When you're dividing, the big thing is they want to divide so that you don't have a remainder. Okay, so you have to kind of think of compatible numbers is how what I call them. You want to think about numbers that go together. So I've got a couple multiplication and a couple division. My multiplication problems, is 32.66 times 7.69. Now, obviously, we could just round them, and I would probably round this to a 33 and this to an 8. So it'd be 33 times 8. Now, I know that you guys can take that, and you can do that off to the side. 24, so it'd be 264. Okay, so estimation, it'd be 264. That's pretty close to exact because we rounded just to the nearest whole number. Now, some of you might also like to take this and you might be like, well, I'm gonna round this to a 30 and I'm gonna round this to an 8 because then I can do 3 times 8 and I get 24 and then I just add that 0, so you get 240. At least you know that you're close. If you get to 240, it's pretty close to 264. So you know that you're in the ballpark, as I would call it. The one thing that you have to remember about estimating is that I might estimate different than you might estimate different than your classmate. It's all kind of what works in your own brain. And you want to just make sure that it's reliable enough to make sure that you're on the right track. So the next one, I'm going to do a couple different examples. So for example, maybe some of you just said, oh, I'm going to round this up to 50. I'm going to round that to a 2, and I get around 100. So you know your answer should be around 100. Maybe some of you like to be more exact. So I'd take that to a 46. Most of the time you can double something pretty easily. So that would bring you to a 92. So you know that your answer should be somewhere between 92 and 100. Okay, so now for division. Division problems, like I said up here, we want to try to divide these without a remainder. And so you want to think of compatible numbers. So right off the bat, I try to think about like what times 8 would get me close to 51. So when I think about that, I'm like, okay, well, I know that 48 divided by a negative 8 would give me a negative 6. I know 6 times 8 would give me 48. I also know that I could take that to like a 50. 50 divided by a 10 would give me a negative 5. Very similar answers. 6 and 5 are very close together. You kind of know what that means. H is a very similar problem. I might have been a typo, but again, what do 51 and 7 or 7 and 8 have in common? What could be close? Well, how about 49 and negative 7? Okay, so my estimation would be a negative 7. You could also, just like I did on the other one, you could do 48 and negative 8, and that would give you a negative 6. Trying to think of what else would be close, but that's kind of like the right idea. So even though these answers or these questions have different decimals, you know that your answer should be right around this ballpark, okay? So they should be close to these. Okay, so the reason why we use this estimation, these examples are kind of helpful to understand why. So it says on a math test, a student worked the problems 55.9 divided by 6.2 and got the answer 0.9. It says use estimation to check whether the answer is reasonable. So this is how you would use it. You'd be taking a test and you'd be like, oh, I divide this 55.9 and you get 6.2. Or you divide by 6.2 and you get 0.9. So let's see if they are accurate. So what could we round to? Well, I have to think of my compatible numbers. What could go together? Well, I think of my 6 and I'm like, oh, 54. 54 divided by 6 gives you 9. I also might think of like, well, this is really close to 56. 56 divided by 7 gives me 8. Or I could take it to 55. 55 divided by 5 gives me 11. Okay, so I have some different values. I have 9, 8, and 11. Is 0.9 close to any of them? And it's not. So that's a red flag for us. That means, is our answer reasonable? No, because using estimation, and I'm going to support my answer here, the answer should be close to, and I want you to show your work, like justify it. Why? How does it close? And then I'm going to say, I think, because this is what I think happened, the decimal is in the wrong spot. And if you look at this, if we would just move that over one spot, it would be 9. So maybe they just divided wrong. They have that decimal in the wrong spot. So that's where it's going to come in handy. That's why we use estimation. Okay, the next problem, it says Kara spent $58.80 on 4.8 pounds of lobster. Use estimation to check whether a $12 per pound is reasonable to spend on lobster. So we're doing dollars per pound. That means that we're going to take the 58.80 and we need to check if we estimate dividing it by 4.8 if we're in the ballpark of $12 a pound. Well, what can we divide by? We could take 60 divided by 6. We could take 60 divided by 5. We could take 55 divided by 5. I'm just trying to think of compatible numbers that we could work with. We don't want to go too far off, but just enough. So 60 divided by 6 is 10. 60 divided by 5 is 12. And 55 divided by 5 is 11. Okay, so what do you think of our answers? Well, they all look pretty close to 12 to me. So by using estimation, I think we can tell that, yes, the estimation is reasonable, or the answer is reasonable. So yes, when the numbers are rounded, and I'm just going to kind of show my work here, we got close or exactly $12. And that's kind of how we can use estimation to see if we're doing our answers correctly.